Hey friends, welcome to section 2 of the course titled Efficient Java Multithreading with Executors, using executors to do everything that you can do with threads. Before beginning our journey on this course, I would like to congratulate you first for making the decision to invest in yourself. Knowledge is power, they say. I hope this course proves useful to you as per your expectations. So let's play. As this is the first technical section in this course, here we will start from the basics and just discuss how to create and run threads using the two APIs. Now, whenever you want to create and run a thread in Java, the basic mechanism is always the same, no matter what API you use. You always need to do three things. Number one, you need to have an instance of thread class. Number two, you need to have an instance of runnable interface implementation that has to be provided to the thread class object. And number three, you need to call the start method on the thread object to start the thread as a separate sequence of execution inside the JVM. Now let us first look at how to use the threads API here. Afterwards, we will discuss the executors API. There are a few techniques to create and run threads using the threads API. And all those techniques differ only in two ways. Number one, the way we create the thread class object and the runnable implementation. And number two, how do we provide the runnable object to the thread class object so that a separate thread of execution can be spawned and the task can be executed in that. Alright, time to look at some code now. Here is the first way of creating threads using the threads API. I have already created a new project called Efficient Multithreading. Inside this project, I have created a class first way that has an empty public static void main method inside it. Now, a thread by definition drives a task in an independent flow of control or a thread of execution. Therefore, we need two things, a task definition and a thread. So I am creating an inner class here by the name of first task that extends the thread class. Thread in turn already implements runnable interface. So we can override the run method in this class to provide the task definition to this thread. Now, as part of the task definition, I am just going to print a statement 10 times inside a loop. Now, we need to call the start method of the thread class also in order to start the thread of execution. For this example, we are going to call the start method in the constructor of first task. So let us create a constructor here. With this code, as soon as we create an instance of the first task class, the start method of the thread class will be called from within its constructor. This will start the thread immediately. So let us create our first thread by creating an object of this class in the main method of the first way class. I am now going to run this class as a Java application. You see that there is also a shortcut Alt-Shift-X and J for running this class. The next time I am going to use this shortcut. The thread has run very fast. We could not even see it running. So let us introduce a small delay in the loop here so that we can witness the sysouts coming in the console one at a time. A delay of 200 milliseconds should be sufficient. Now I'm pressing Ctrl Shift O so that the import for time unit automatically comes in. The sleep method here throws an interrupted exception, which is a checked exception. So we need to surround it with a try catch block also. And let us put two sysouts in the main method also, so that we can distinguish when the main thread starts and ends, and when the spawn thread in which the first task executes starts and ends. Running this class now. There. The output was a little slower this time, and we could see the individual sysouts coming on the console. From the output we see that first the main thread starts, and then it spawns the second thread, and before the second thread could get the CPU to execute, the main thread ends. After that, the spawn thread executes and prints the countdown messages one by one. Now, what if we want to spawn a second thread as well? For that, we just have to create another object of the first task class. This will create a new task as well as a new thread, and then start executing the task in that thread. And by the way, you can also capture the thread reference here while creating the instance of first task. If you capture the thread reference, then you can do all sort of things with it later. You can rename the thread, join it, check if the thread is running or has finished, etc. We will cover all these things in detail in the subsequent tutorials. Now, if we are running two tasks in parallel, then we also need to identify from which of the two tasks each of the tick-tick output in the console is going to come. So we need to provide an identity to each task and print its identity information also along with the tick-tick messages. So let us do that. Here I have created a static integer variable count and a private integer variable id. This id will be the identity of the task. Every time a new instance of this class is created, we are incrementing count by 1 and then assigning the resulting value to the id variable. So each new task instance will get a new id. Let us also print this id in the sysout. Let's run this class again. Here again the main thread starts first and then it spawns the other two threads. The first thread gets the CPU and it prints tick tick 10, and after that the main thread ends, and then the two threads continue running till they finish their natural course. In reality, you do not know which thread is going to get the CPU when, so you won't get the same output every time you run this program. The output will be similar but not exactly the same. So in this method of creating and running threads, the thread object and the runnable implementation both are provided by the same class. In our example, that class is first task. In order to start the thread, the start method is invoked from the constructor of the first task itself. So as soon as you create an instance of this class, the thread also starts immediately. This brings us to the end of this tutorial. See you in the next video now. Till then, take care and bye.